So in this lesson, we're going to be looking at the reciprocal trigonometric functions. The reciprocal trigonometric functions are sec, cosec, and cot. And in fact, these are abbreviated from secant, cosecant, and cotangent. Oops, let's correct that spelling. If we consider the right-angled triangle that we used to work with for standard trigonometric functions, so for SOHCAHTOA, sec theta is defined as the hypotenuse over the adjacent, cosec theta the hypotenuse over the opposite, and cot theta the adjacent over the opposite. This means that since sec theta is hypotenuse over adjacent, it's equivalent to 1 over cos theta, because cos theta is adjacent over hypotenuse. Cosec theta, since it's hypotenuse over opposite, is equal to 1 over sine theta, since sine theta equals opposites over hypotenuse. And cot theta is 1 over tan theta, since it's adjacent over opposite, and tan theta is opposite over adjacent. It's worth noting at this point that 1 over tan theta is equal to the inverse of the trigonometric identity sine theta over cos theta, so cos theta over sine theta. Okay, so let's have a look at the basics and what we're going to do with these functions. In this first example, we just want to evaluate sec 58. So this is in degrees, in case you're unsure. So sec 58. Now, if you note this bit down at the bottom, the third letter of each reciprocal function indicates which of the original trigonometric functions it is a reciprocal of. So if you just quickly check this, you see sec, third letter of that is c, and the first letter of the normal trigonometric function is c. Cosec, the third letter is s, and the first letter of the trigonometric function is s, so it's sine. And cot, the third letter is t, and so the first letter of the trigonometric function is t, and so it's tan. So when I come to this question, sec theta, what I know is this third letter here relates to the original trigonometric function it is a reciprocal of, so that means that this is the same as 1 over cos of 58. And so all I have to do is evaluate this on my calculator to get an answer of 1.89 to 2 decimal places. And that's all we have to do to evaluate these trigonometric functions. Now, didn't even really bring out the use of calculator here, but you will not find sec, cosec, and cot on a calculator. So we have to use these reciprocal trigonometric functions. In this case, it's fairly straightforward. In the next couple of examples, it's a little bit trickier. So in this example, we're asked to solve the following equations for the range specified. So I'm asked to solve 4 sec theta equals 8 in between the range 0 to less than or equal to theta, less than or equal to 360. And I'm asked to solve cot 3 theta minus 20 is equal to 0.25 in between 0, less than or equal to theta, less than or equal to 180. Okay, so let's look at the first example. 4 sec theta equals 8 in between this range. So if I was solving this, first thing I'd do is I would divide both sides by the coefficient of sec theta. So I divide by this 4, so I just get sec theta equal to some value. So I get that sec theta is equal to 2. Now what we know at this point, I can't evaluate sec theta, there's no inverse sec function on my calculator. So this is the same as 1 over cos theta is equal to 2. Now there's a couple of ways we can go about rearranging this. I'm going to show you both ways just so that you can pick which way you're most comfortable with. I want to get cos theta isolated on its own. So if I multiply both sides by cos theta and I divide both sides by 2, I get that cos theta equals a half. And all I've done is I've swapped the sides around so it reads in the order that we'd usually read this. There is a slightly alternative way that we could approach this and consider this. If we have 1 over cos theta equals 2, and we take reciprocals of both sides. And what I mean is invert fractions. Okay, what we get, if I put a 1 under there just to make it clear that 2 is 2 over 1, we don't usually put this, but in some cases with fractions it helps to have this with us. If I take the inverse of this, what I get is cos theta over 1, and if I take the inverse of this and invert it, I get 1 over 2 instead. And again, this bit here I wouldn't necessarily write. But what it does is it now gives me a trigonometric function which I can solve, because I can now take the inverse of cos to find theta, and that is on my calculator. So here I get theta equals 60. I want to find all the solutions in the range 0 to 360, so using a cast diagram, C, A, S, T, draw 60 degrees into the cos quadrant. So here's my 60 degrees. I need to know what is the angle all the way around from the positive x-axis in an anti-clockwise direction. This is 360 minus 60 degrees. So the other solution is 300. Remember, at this point, we want to try and generate more solutions. Add or subtract 360 to this solution, and it falls outside this range. Add and subtract 360 to this solution, it also falls out of this range. So we finish at this point here. So actually, solving equations involving sec, cosec and cot is exactly the same as what we do in C2. The only difference is this extra step where I have to go from the reciprocal to the normal function equal to some numerical value. Okay, so let's have a look at part B. Part B, we have to solve cot of 3 theta minus 20 equals 0.25, and I'll solve that in the range 0 less than or equal to theta less than or equal to 180. Please remember, for this I have to transform the range so it matches. So when we approach these questions, the key to these questions is you've got to transform the range which you're going to find your solution to match the range in the actual trigonometric equation. So what I'm going to do here is I'm going to times by 3 first of all, so that I get 0. Let's do this in black because actually this is part of the question, it's not additional notes. So we get, try again, 0 less than or equal to 3 theta less than or equal to 540. And then I'm going to subtract 20 from both sides, and then I get the range matching up. So I get minus 20, sorry, it's add 20 to both sides. So I get plus 20 less than or equal to 3 theta. It is minus 20, sorry, apologies, I don't know what I'm doing here. Minus 20, so minus 20 less than or equal to 3 theta minus 20 less than or equal to 520. Okay, so at this stage, what I now know is I want to solve the trigonometric aspect of this problem, so that's where I want to find all my possible solutions for the trig part of the equation in between minus 20 and 520. Once I've done that, then I can solve the algebraic equation part of this problem. So I've got cot 3 theta minus 20 equals 0.25. I'm actually going to write that as a quarter because that'll make life a little bit easier in a minute. Now what I know is cot 3 theta minus 20 is 1 over tan. 3 theta minus 20 equal to 1 over 4. Now personally, I like taking the inverts of both sides, which is why I wrote this as a fraction. So if I invert this now, I'm going to flip this fraction upside down, and I'm just going to write this as tan 3 theta minus 20. I'm not going to bother writing over 1. It's equal to, invert the second fraction, that's going to be 4 over 1, but I'm not going to bother writing the over 1. So now I just need to solve tan 3 theta minus 20 equals 4. I'm going to take the inverse tan function so that I get 3 theta minus 20 is equal to, so taking inverse tan of 4, I get an answer of 76.0 degrees. Okay, so at this point, I mean, it is possible to use a cast diagram to find a tan function, but it's far easier just to remember that for tan, any additional solutions, you just need to add or subtract 180 because the graph repeats every 180 degrees. So my other solutions are 76 plus 180, which equals 256.0. I can still keep going, so let's add another 180, 256.0 plus 180 equals 436.0. If I add another 180 degrees, it's going to go outside that range of 520. And clearly, if I subtract 180 degrees from this, it's going to go outside the range of minus 20. So at this point, I now know that 3 theta minus 20 equals 76.0, 256.0, and 436.0 degrees. Okay, and at this stage, and I'll make a note of this, this is the important part that comes from C2 that doesn't always get done. Trig equation is solved. And you must remember that you must find all the possible solutions in the range that matches to this transformation before you even think about solving this algebraic bit. The algebraic bit is the last bit. That's nice and straightforward, but you have to do the trigonometry first. So first of all, to solve the algebraic bit, I'm going to add 20 degrees to each one of these solutions, so I get 3 theta equals 96.0, 276.0, and 456.0. And then I'm going to divide all my solutions by 3, so both sides of this by 3, so I get an answer of 32.0, 92.0, and 152.0, and all of these are to 1 decimal place. Okay, well, I hope that all made sense and that you was able to follow my solution.